Okay, welcome folks. My name is Eric Fennicus. I work at PwC. I actually came to PwC as an international tax lawyer, and now I lead data and AI for our Canadian tax business. My wife likes to introduce me as doing nerd stuff, but my retort is that I actually came from international tax law, which is more nerdy, and now I'm doing cooler stuff in data. But I'm here to talk to you today about the data utility architecture, or I'll say DAO for short, DAU, just so I don't have to keep repeating that. It's something I've been working on and running in production for a little over 2 years. I'm going to start with some broad concepts, the way that I like to think about enterprise data architecture, dig into a few of the core concepts that we use, and I'm going to try to get to the last portion, which is the patterns that you can use to implement some of these things as quickly as possible. Try to get to that with about half the session. And so what is it? It's a framework that's built for the enterprise. What that means is it's built to handle data sprawl, applications, uses across a very large enterprise. It'll work in smaller situations too, but that's been my focus. And broadly, we do that by combining some of the best modern approaches to data management. And so the things that I'm talking about, for those of you who are experienced here, there's nothing new. One of the core concepts is to focus on data first, not the applications, not the services. The first priority is where the data comes from, where it needs to go, and what's going to happen to it in between. It's also built on the Lakehouse, which allows you to store any data, transform it, and present it, make it available for any purpose. That also means that we don't need to distinguish between operational and analytical data planes or any other kind of arbitrary distinctions. We focus on creating data products that are fit for purpose. And so, although I disagree with that view in the data mesh, which is distinguishing between data planes, the core data mesh concepts that can be applied to expand your data utility across many data owners and across the enterprise. So the goal here is primarily the focus on data, growing the value of your data. That's because the value of data comes from how it's used. And so what I'm going to talk about, the focus on building data products, means that we focus on making data valuable for our consumers. And as you create more assets, you're able to gain leverage on those existing assets to create even more value. Personally, I've been through some data and digital transformations. I'm sure many of you have or are doing so. And what I've found is that small steps are how you succeed. And what that means is you need a fast time to value. You need to take small chunks, right? Rather than go and say, let's overhaul our entire enterprise data architecture with this big new idea. Instead, let's focus on a way that we can take one step at a time and build this out. And in terms of making things as future-proof as possible, I heard Jeff Bezos talking on a podcast about creating an agile organization by shutting as few doors as possible. And again, that's what we try to do here is as we make decisions, we just don't want to shut down the future possibilities of what we're going to be able to do. And so let's talk really high level. How do I think about enterprise data architecture? What I see a lot of the time is an application first mindset. I think of it as a very vertical mentality to design. What that means is each application is going to have its own integrated infrastructure, right from the database all the way up to the UI. Everything is built around this application and serving it. It can be a microservice or just call it regular service or a monolith. It's all built around that service that's being built. The translation for that, in my view, is a data silo, right? And so that may be good for your application that you're building. It may not be as good for your entire enterprise that also needs to use that data and be able to leverage it. And so the solution in many approaches, and in the original data mesh, for example, is to create bridges between these applications or silos, right? And so in the data mesh, you can create APIs to access the data. We may also create ETL or ELT or other acronym pipelines to extract that data and dump it into data warehouses, lakehouses, data marts, what have you. But in all of those cases, and the reason this picture is up here is that view of data is like it's exhaust from an application that needs to be captured and moved somewhere, right? And so the primary view is on the application. And so when I talk about data first, I'm talking about a horizontal view or a horizontal approach rather than this vertical one, where the goal is to have this underlying data layer that powers your enterprise so that data can flow freely across the enterprise, pop up where it's needed, right? And so we have this nice generative AI created image where you can see all your pipelines running underneath the city. And there might be a factory that has a high data need or high water need. There might be houses where you just want to turn on the tap and data is available. It's also a good way to think about what we're going to do with data, which is where does the data come from, what do you need to do with it, and where is it going to need to end up? It's going to come from some source. We're going to need to do some cleaning steps. We're going to need to process it in some way. We're going to have to make it fit for purpose, right? Like in the case of water, for example, it's one thing, but it's going to be used in many, many different ways. And so the nice thing about this is that the thing that's most durable is the pipeline itself, the data pipeline. So in my world, in the tax world, I'm always going to need to take our client's data, transform it, and put it in a tax return, right? That's what we do. What we do in between that, how we change or work with that data might change. So for example, I might need to take a client's financial data, map it to something that fits into a tax return, and then push it into that system. And today, maybe I'm doing that by creating an application. And so I might have my data pipelines running. I'm going to create a data product that surfaces that data. And then I'm going to allow people to do the mappings manually. Maybe once I've got a number of labeled sets, I can apply some machine learning to help predict, right? But then generative AI comes along, and instead of having a mapping application, maybe I want to transition to having the LLM predict what the mappings, and maybe it's going to reach out to the engagement team on Teams and just ask them, hey, is this mapping correct? Right? That's a totally different interface to working with the underlying data. And it's very easy to change that if what you focused on is a data pipeline, where you're moving data from one place to another and you're just popping it up where it needs to go. And so it's that data first. The data piece is durable. The interface, the UI, whatever you're going to do with the data is sort of interchangeable and almost a throwaway. So getting into some of the core concepts, this is the opinionated piece where I have strong opinions when I talk to my team about how we do it. We use a medallion stratified lakehouse. We used event-sourced data streams. The streams and the event-source piece are very important. And we build data products. I'll keep it on this for just a second for anyone who wants to take photos, but I'm going to go into each of these in a little bit more depth. If you've been around Databricks conferences for any amount of time or been using Databricks, you've heard about a lakehouse, you've heard about the medallion architecture. It's bronze, silver, gold. Personally, I like to refer to it as raw, semantic, and presentation. This mostly comes from when I was talking to a business user a while back, and I was talking about bronze, silver, gold, and he said, oh, does that mean the bronze data isn't good data? It's like, no, it's just different, right? It's raw data. It's not bad or it's not good, it's just raw data. And so it's a little bit more meaningful. To me, the most important two pieces are that raw data layer and the presentation layer, right? So raw data, you don't touch it. You bring it in, you put it there, and you don't touch it. You can update it, but you're not going to do any transformations in that layer. Even if there's bad data, even if there's nulls, you're not doing anything there because you never know what you might want to use that bad data for. It might turn into good data a year from now. The presentation layer is where data is accessed. It's where people interact with the data, your consumers. It's where you put your data products. What happens in between? right? Like what I call the semantic layer, or it could be the silver layer. I've seen blog posts or webinars where people, that could be 3 layers for some people. It can be 1. It doesn't really matter. What the point is in the middle, that's where you do your transformations, right? Maybe you're materializing data. Maybe it's a stream, maybe it's batch, but that middle piece is where you transform it. And notice here, I'm not going to talk too much about the difference between this, more just the common approach of, if you have a data mesh or something where you're pulling data out of all these different sorts of systems and using it, versus a Lakehouse approach. We can actually treat dashboards and applications in the same way. They're both just consumers, right? And you could put your data science team up there. You could put your business team up there. It doesn't matter. Consumers are just people who are a group. It can be people. It can be an application who need access to data, and they need to do something with it. And our job is to design the products that allow them to do that. Event source data streams, the main difference here is that rather than overwriting things as they change, it's just append only. Every single change gets appended to an ever-increasing log. Obviously, it can't be ever-increasing. You're going to run into problems, so you can get into things like compaction and other things. But the idea is that every time data changes, that change gets appended to the end of your, and this is in the raw layer at least. You can use that later on if you want to. But so for example, in something like SQL Server, where they have change data capture, right? It's an example of event source data. They actually give you the option to, I forget the word they use, but essentially combine a bunch of updates into a single record. And I always turn that off because I want every single record. Right? If you can see the changes that are happening, it gives you a lot more flexibility to build data products that your consumers might want. Because it goes back to that future-proof thing I was saying at the beginning. If we don't know what people are going to use the data for, we don't want to make assumptions and either aggregate it or change it too early. It's really about getting that raw layer set with event source data and leaving it there to do what we want. The other piece is to build these as streams. And to make this clear, this doesn't mean that every single data pipeline you use has to be running a stream 24/7. With something like Spark Structured Streaming, you can design your pipeline as a stream and run it once a day. Right? It's just that when you build the pipeline, you use, if it's Spark, a read stream instead of a read, and there's a few things you have to do that you can't do in batch, and vice versa. But what that gives you is a knob that you can turn to change how often your data is updated. And so if on day 1, your consumer comes to you and says, yeah, I only need this data updated once a day. Okay, great. You're still going to design it as a stream. It's going to be event sourced. You're going to bring the data in. You're going to do your transformations and make it available to them. Because then, if they come back to you 2 months later and say, this is amazing, how fast can you make it? You can say, oh, I'll just turn it up. Right? Are you willing to pay the cost of the streaming pipeline? Yes? Okay, great. You scale it up, right? Whereas if you've designed your pipeline from the beginning as a batch process, there's only so far you can scale that before it starts to get really, really expensive. And you can do this, you can write to files and use something like autoloader. You can write to an event topic and stream from Kafka. I haven't seen any sessions on it, but I've heard of the Python source in structured streaming, which I'm excited about. And so our last kind of core concept is data products, which you've heard me mention a couple times, right? And so on one view is you can have a dimensional model, right? And this is what we might see in a traditional data warehouse, where you design the model specifically for a specific use case. And that itself could be a data product, but in a typical warehouse, you're doing all of that ahead of time. In the data utility architecture, you're going to do that at the time a consumer comes and asks you for something, right? They're going to say, we need data to do X. Feed an app, feed a dashboard, run some analytics. Maybe that means creating a dimensional model, and you can do that with streams. Right? And so that's one example of feeding a dashboard. On the other hand, maybe it's creating a RAG application, in which case you're going to feed your data into a vector database and some AI models. Maybe it's something else, right? And so a data product is just a collection of data assets that are fit for the consumer purpose. And personally, I'm actually still exploring what it means to have a data product. In my view, it could be an in-memory database like Redis with Delta Lake tables, streaming updates into both, and a read-through cache pattern. There's no reason you couldn't have a transactional database like Postgres, or a NoSQL database, or a graph database as part of your data products, right? It doesn't have to be something that just lives in a table or a single database or anything else. The key commonality, though, is that it's powered by a Lakehouse, and it's using the streaming event source data to manage it, to fill it with data. But otherwise, there's no limit on how you put those pieces together to create a new data product. And this is why the distinction between like analytical and transactional data planes is irrelevant, because it actually artificially limits your imagination and your capability. If you define everything as transactional or analytical, Postgres or NoSQL, you're going to be picking things that fit some of your use cases, but not all. And I'll show you one of the patterns later as an example. So instead, think about exactly what your consumer needs and just pull those pieces together, right? It's almost allowing you to deconstruct the database into the pieces that you need for a particular purpose and then put them back together, right? It gives you those Lego blocks. And underneath, it's still that horizontal layer, right? As long as you have that Lakehouse, that raw data layer, you can be using and reusing all of your data sources across all of these data products. And finally, if you want to expand that, you can add on the idea of a data mesh, right? And so this isn't something where you have to have one central data team that owns the whole thing for the organization. And in fact, I personally wouldn't recommend that. This is where the ideas in the data mesh are great. The idea of a domain ownership, right? So I lead tax data and AI, and I have our DAO, our DataOps platform, for example. Because I'm a tax lawyer, I understand that data better than anyone else in our organization. And other groups in our organization can equally own their own data. And then it's just about finding the interface. You know, something like delta sharing is a great way to share data between these systems, right? And so you can still have the idea of a data mesh that allows you to scale out. It doesn't have to be one central team, right? And the idea of a data product comes directly from data mesh, as well as federated governance. Personally, just again, for those who really know the data mesh concept in detail, the one point I do disagree with is that you need a full self-service approach to cataloging and discovery. A lot of people want, you know, the data catalog where anyone can just go in and search for any data that they need. That I'm sure that's very useful in a lot of organizations where it works. I personally haven't seen it and haven't seen how it'll work well in my organization, just because of the work that's required to catalog that data, make sure that it's well documented. And what often ends up happening is even after you've documented all that data really well, someone's gonna go and look at it and then still have questions and reach out to you. And so what we've done is we have a data products lead who is the expert on all of this data, and people just go directly to her and say, hey, I need this. And she'll say, yeah, we have that, okay, let's build you a data product, right? Or maybe if you're using some of the new Databricks features, you can use something like a Genie space to make data available in that way. But again, that's more of a, you know, what works in my organization may not work or in others and vice versa. So like I said, we have about half the time left, which is perfect because the implementation patterns to me are the most interesting and hopefully to you as well. And so the first one is less of a pattern necessarily, is where do you start? I said you should be able to start with quick wins, short steps, right? And so this is exactly how I got started, which is to identify a single problem, go and find the data source that's gonna solve that problem, build your pipeline, and build the data product. And so in our example, in tax, out of the tens of thousands of tax returns that we file every year, around 45% of them are due on a single day. The other 55% are due the rest of the year. And so that means we have a huge peak capacity problem. It also means that the people who are managing those final due dates on those major days need to know down to the second how many have been filed, what's the status, who's working on them, is anything stuck, because we're liable for the penalties if we're late. And so this was a big problem. We went out and found the data sources from the workflow systems. We built the streaming pipelines, and we fed them into a dashboard. Rather than saying, today, I own all the data for tax. I'm going to go out and everyone has to implement this system across all of their tools, which takes years just to talk to everyone. This approach of just identifying a problem, solving that problem, it's easy to do on day one, and you can show value right away. And then you do it again, right? And you do it again, and you do it again and again. And a year, 2 years down the road, what you end up with is a pretty substantial data platform with a whole lot of data sources, feeding a whole lot of different data products, and creating a tremendous amount of value for your organization. And at that point, you can start to think more about, okay, how can I combine this data into new ways and do new things, right? How can we leverage large language models and RAG and everything else that we're learning at this conference and elsewhere? But starting small and growing really is important because, in my view, in a lot of these cases, things like institutional knowledge and institutional capability are undervalued and not talked about enough. It's not something you can hire for, right? It's something that, as an organization, you need to learn, depending on your level of maturity. Like everyone's organizations are at different levels of maturity, but it does take time to do that. And so that's why taking these small steps really works well. So this is the first example of a pattern we developed, which is, okay, how do you build an application fed by something like Delta Lake? Delta Lake, you can't do heavy write loads into Delta Lake tables. It's not going to work. It doesn't scale. In fact, not only does it not scale, it really breaks down fast. And so instead, use a pattern called command query response segregation, or CQRS. Right? The opposite is CRUD, create, read, update, delete, which most of us would be familiar with. CQRS is a little bit less common, but the idea is you materialize data in a data product. Your consuming app, your consumer, it could be a dashboard, but in this case, an application, reads from that source, and you write to somewhere different, right? So that's the command and query response segregation. You read from one place, you write to another. So if that is a Kafka topic, and then you build a stream that updates your raw data, pushes it through to your gold or presentation layer, you can get that latency down pretty low depending on the load that you're looking for, right? I mean, again, Spark structured streaming has been speeding up year over year. Depending on how you build that pipeline, it could be sub-second. But for this, you do really have to lean into eventual consistency. Right, and that's, in my view, a good thing, because although strong consistency is important in some applications and is possible, in most cases, it breaks down quickly when you get beyond a very small scale. And so instead, designing from the start for eventual consistency, meaning your data will be eventually up to date, and eventually can be milliseconds or seconds or minutes, solves a lot of problems. It solves ideas of concurrency, conflicts, race conditions, scale. And so this pattern also aligns with users taking action on data, right? This idea of we have a data pipeline, we want to build an interface into the data in some way. We want to enforce things like order and item potency, whereas many applications will assume there's only one person working on the data, and then they'll implement things like locks to enforce it. In this approach, we don't require those assumptions. We don't need to deal with locks and race conditions and anything else because we have an ordered list of every single thing that's happened one at a time. The other major benefit is it brings processing out of the database. Right? Databases are built for storing data, or that's what, in my view, they should be used for. That said, I've worked on projects where we use triggers and stored procedures to implement business logic. I can tell you it didn't work well, and for those of you who have done it, you would probably agree. But even really popular industry books like Designing Data-Intensive Applications, they talk about using databases that implement conflict-free replicated data types, right? They implement conflict resolution in the database. Personally, I'd prefer to implement that myself and explicitly so I know exactly what's happening. If there's a conflict to be resolved, I don't want the assumptions of my database to do that for me. And so with CQRS, especially if you're writing to something like a topic that forces order, you can much more easily deal with those issues. And then when you do build this, the nice thing is you need no new data infrastructure. I mean, I said at the beginning, you could use NoSQL databases or anything else as part of your data products, but in this case, you don't have to, right? I'm sure many of you are using Databricks. If that's what you're doing, your app can connect directly to Databricks, and it sees a database, right? And it writes to an API. It's the exact same thing as if you did have something like a Postgres or a Cassandra. But at the same time, you have no new data silos, right? All that data is fed right back into your Lakehouse for reuse across other applications and for other people. This one's an interesting one. It's an extension of the previous pattern. And it's a great example of why the operational versus transactional data plane kind of split is, in my view, irrelevant. So we have tax calculation applications. Users are going to upload their data. It's going to process the data, transform it, present it back to a custom application that we build. In this case, clients might upload a few 100,000 rows. It's typically in a CSV. Excuse me, they might upload 50 million rows, 100 million rows. We need to be able to process all of that data and get it back to the users. The client application is going to lazy load that data in, but then those users are going to are allowed to slice and dice the data, right? So 50 million rows of filtering for a specific word gets pretty difficult if you're using something like a SQL database. So instead, what we did, I have this as a serverless function. This could be a node backend, right? It's just something in the backend of your application, where you're going to, let's say you filter on a column. Instead of trying to apply that filtering directly on a database, you can use something like Spark Connect in your backend, or you can use a SQL warehouse to do that for you. You're offloading that processing to something that's built for large-scale data processing and aggregation. If you want to do calculations on the data itself or updates, writes to the data, right? So imagine a user is filtering, looking for null values, and they want to do some manual updates. You can do that too, exactly like we did in the last pattern. They fill in the null values, that gets sent off to a topic, streamed into the back end, updated, presented back to all of the client systems. If you want it to be, to have really low latency, you could use concepts of optimistic concurrency. So I update null values, my application assumes that it's right, it shows me that it's been updated, and it just polls the back end to make sure that that's correct once it's been updated. But in this model, people can be updating individual rows in this 50 million large table at the same time as other users are aggregating over that exact same table, which would be very difficult, again, in a SQL Server model where it would have to be locking down some of those rows. You'd be implementing no locks. You would still have eventual consistency, but you would just have a little bit less control over it. So again, this one is less of a new pattern and just more getting at how we implemented this idea of a data utility architecture 2 years ago. For me, at least, before LLMs were really on the radar. But then what we realized was that we had been ignoring this huge area of data, which is unstructured data. And so, but because we have a lakehouse, we didn't need to change anything about what we were doing. Right? Data still gets ingested into the raw layer. It still gets transformed in the semantic layer. And it still gets presented in the presentation layer. There's just difference in the tools that you're using. So instead of transforming with the native Spark functions, I might be doing some chunking and embedding in the semantic layer. And instead of putting it into a Delta Lake table, I'm putting it into a vector database. Maybe I'm training an AI model. But the overall pattern is the same. And so when you're using this approach, when something in the industry changes, you need to access new data, you need to use new tools, your approach can remain the same. And from day one, you can start working on that rather than needing to go back to the drawing board and re-architecting your data platform. And so in our example, we needed to extract entities. In tax, we deal a lot with law. So references to legislation, the sections in that legislation, court cases, other legal information. Because those extractions live in the semantic layer, it's easy to reuse. So we're going to extract those entities and use them in a reference graph to power better retrieval. But we can also use them to train or fine-tune a custom named entity recognition model, or to fine-tune a task-specific large language model. That large language model, as a data asset, can be used as part of our batch processing pipeline to extract more entities. It can also be used at inference time to better understand the intent of a user, right? And so compare that with a very common approach that I've seen when people are trying to stand up like a RAG POC, or maybe even a production application, which is identify the vector database you want to use, go and find all your data, chunk it, embed it, get it into the vector database, and then build your RAG application on top. Again, thinking back, that's that vertical approach that's going to work. I'm sure it'll work well for that application that you want to use. But when it comes time to reuse the data for something else, right, to fine-tune a model, even build some analytics dashboard, this approach is much more similar to data warehousing, where you've made it fit for purpose, you've put it somewhere, and then it's kind of stuck. It's not ready to be reused. And so if you want to reuse it, you actually have to extract it back out of that database, which puts extra load on the production system, and in the end is kind of difficult to track your data lineage. And so the final pattern, and here, full disclosure, this one I haven't implemented yet. It's one that we've been discussing internally that I'm kind of excited about, so I wanted to talk about it. The use case is, say you have a single data provider in your organization serving many, think hundreds or thousands of consumers, where the data is changing very fast. There's a lot of data, it's changing really fast, but for any one consumer, it may be slow. And also, you have to segregate that data by consumer. So, I'm not allowed to see anyone else's data, they can't see my data, and so on. So, one approach you can use for that is to create a dynamic view, right? So you can materialize these transformations in a stream, and then you can create a dynamic view on a single table that says, Eric is allowed to see these rows, person B, person C, they can see these rows. The problem is, if I want my data to be updated fast in some other system, I can't stream off of a view, right? And so if I know my data is going to be updated a bunch of times during the day, I don't know when, and I can't stream, this pattern is meant to deal with that situation. And so it's exactly as I said, the data provider is bringing in their data, they're streaming, bringing it into raw, doing their transformations in Silver. But what they do is instead of just materializing the data in a table, they also materialize the data in a separate topic. The topic can even be partitioned by data consumer ID, for example. And then I, as a consumer, can listen to that topic, wait for an update to my data, and then read from the view. If I implement this as a Lambda or Azure serverless function, that action can be quite fast. And so I effectively get the benefit of something that's streaming or nearly as fast as streaming without having to keep a streaming pipeline on all the time. Because, again, if you were thinking of hundreds or thousands of consumers and you're keeping 1,000 streaming pipelines on 24/7 just to get a few updates each per day, that will get very, very costly. And so this is a pattern to deal with that we're exploring. Definitely over time. Thank you, folks. If you have questions, come on up.